Bernoulli and fluid movement. Just as balloons and ships float in the atmosphere and in water, respectively, according to Archimedes' principle, they are lighter than the air or water that they displace. Airplanes and other objects in flight do so according to the Bernoulli principle, which states, sideward pressure exerted by a moving fluid decreases as the fluid's velocity increases. As a plane moves through the air traveling over the curved upper surface of the wing must travel farther up and over the wing than the air traveling under the flat part of the wing. That means that the air traveling above the wing must speed up temporarily and, by the Bernoulli principle, exert less pressure on the wing than does the air beneath the wing. This difference in pressure over the whole surface of the wing pushes the wing up toward the lower pressure. This upward force is called lift. Several factors affect lift. Speed. The faster the wing moves through the air, the greater lift it produces as it creates distortion between the pressure field. Tilt. A pilot can also increase lift by tilting the aircraft. Perhaps you have noticed that airplanes taking off and landing have their noses higher in relation to the back of the plane than they do in normal flight. This increases the plane's lift at slower speeds. Shape. Changing the shape of the wing also increases wing lift. This is especially important at low speeds because lift must overcome the force of gravity if a plane is to fly. Thrust. This is the force created by the engines that drives a plane forward through the air, allowing the wings to create lift. Gravity and drag resistance are the two forces that slow the movement of a plane. Drag is caused by friction with the airplane's surface, the inertia of the air that is resisting being moved out of the way, and the pressure difference ahead of and behind the airplane caused by its motion. Remember Newton's third law of motion: for every action, there is an equal and opposite reaction. This principle is at work, causing resistance and back pressure to build up behind a moving object. To reduce drag, the aircraft surfaces are smooth and shaped to efficiently push air aside and allow the air pressure fields to come smoothly back together behind them. Streamlining is the science of shaping objects so they allow the easy flow of fluids around them. Oddly enough, smooth surfaces do not necessarily have less drag than non-smooth surfaces. For instance, the dimples on a golf ball allow the ball to displace less air as it moves and create a field of lower pressure behind the moving ball. Do you like working with tools? Have you ever spent time hanging out in a home workshop? Or have you ever attended a shop class? If so, you will probably find this section of the Asvab easy and maybe even fun. However, if you've never picked up a wrench or swung a hammer, you might be at a disadvantage. This chapter will help get you up to speed. The Shop Information (SI) module identifies people who understand shop tools, materials, and processes for placement in career fields such as facilities or maintenance. Although you should do your best on all Asvab modules, if your career includes shop work, such as a machinist or carpenter, this section will not be as important to you. Because this module is not part of the AFQT, your score on it has no impact on your enlistment eligibility. On the CAT Asvab, shop information is its own module, but in other versions of the test, it is combined with automotive information in the automotive and shop module, AS. Because of the overlap, the discussion on tools talks about both shop and automotive applications. In this module, you have to answer 25 questions in about 11 minutes. This chapter overviews the material you're most likely to see on the module, starting with a look at the most common tools, and then a review of shop processes and planning techniques. This type of information is most easily absorbed through hands-on exposure, so your best bet for more understanding is to visit a hardware store or a friend's workshop where you can see and handle tools and ask questions. Tools of the trade. We use tools to every day to increase our mechanical advantage and make work easier and more consistent. Tools fall into two primary categories: hand tools and power tools. Within those categories are many types of tools for many types of jobs. In this section, you will learn about different kinds of tools and their associated parts and how to use each one. To make learning them easier, we group them according to use: measuring, cutting, drilling, shaping, and fastening. Shop safety. This is a good time to talk about the need for safety in the shop. All tools, regardless of whether they are hand tools or power tools, have a set of established practices for their use. You should always abide by those practices and exercise caution and diligence when you work with tools. Use a tool only for the job for which it was intended. Using a tool improperly could cause injury or damage. Always implement certain practices every single time you are doing shop work. Always. Wear safety glasses to protect your eyes from flying debris. Wear gloves, whenever practical, to protect your hands and fingers. Wear safety shoes to protect your feet from falling objects. Wear clothing that is tucked or close-fitting, especially when you are using power tools, to keep your clothing from being caught in the equipment. Follow the manufacturer's instructions explicitly. Likewise, never, ever practice other things, to avoid injury, or even fatality. Never. Pull sharpening tools, such a knife or file, toward your body. Push them away from you, to avoid cutting or stabbing yourself. Work alone when you are working with heavy equipment or components. Work alone when you are working with electricity. Work alone when you are erecting any form of structure. All tools, if not used properly, can potentially cause injury or even fatality. Make sure that you know how to use your tools, either by apprenticeship mentoring or by reading and following the written instructions. Measuring systems and tools. Although every shop project must maintain a certain degree of precision and consistency, a close, precise fit and interchangeability are especially important in mechanical repair. For this reason, mechanics have defined technical requirements and specifications that they must follow. To do so, a mechanic must be able to make precise measurements and adjustments within specified tolerances. The following sections discuss the measuring systems and tools that you will use in most everyday shop projects. Measuring systems. Before you can learn about the different types of tools, you must understand the measuring system that those tools use. The English system is the most common measuring system used in the United States. This system states specifications in inches or fractions of an inch, the most common of which are 1 inch and 1/2, 1/4, 1/8, 1/16, 1/32, and 1/64 of an inch. However, work that requires measurements less than 1/64 of an inch uses decimals of an inch to indicate. Size: 1 inch is divided by 10, 0.1, each tenth is also divided by 10, and so on, to 4 places after the decimal, 10,000ths place. The metric system is the measuring system that most of the world outside the United States uses. The basic unit is the meter, which is divided by and multiplied by factors of 10. In the metric system, larger and smaller units are relative to the meter, as indicated by a prefix. For example, 1,000 m is a kilometer, km, because kilo indicates 1,000. Likewise, 1,000th of a meter is 1 millimeter, mm. If you